Today we are going to factorize P of Z over the real field, the complex field, and the rational field. So it's best you factorize it over the complex field first, and then you do the rest after. So given that 1 plus I rather is 0 of Pz equals Z to the power 4 minus 2Z cubed minus Z squared plus 6Z minus 6, by the conjugate root theorem, since all the coefficients are real, 1 minus I is also a 0. So what that means is then, you know then, that Z minus 1 plus I and Z minus 1 minus I is also a factor. So that means that when you expand that in a hurry, you get Z squared minus 2Z plus 2. So then you go, all right, Z4 minus 2Z cubed minus Z squared plus 6Z minus 6. I'm about to do what is called, by the way, quick division. You heard of long division? This is short division. So Z squared minus Z plus 2. So of course, Z4 divided by Z squared, you get Z squared. That's the first guy. And of course, 6 divided by 2, you get minus 3. Using another thing called integer root theorem. Or not really. But anyway, that's quick division. So the only thing left in the middle is AZ for some value of A. And you try to work out what A is in this case by equating the coefficients of Z cubed. So if you equate coefficient of Z cubed on both sides, on the left you have minus 2, as you can see. On the right, the only way you get Z cubed is to go Z squared times AZ, which is A, and then minus 2Z times Z, which is minus 2. That's the only way you get Z cubed. So that means then A equals nothing, according to this equation. So what does that mean? It means that Pz then is equal to Z squared minus 2Z plus 2 and Z squared minus 3. That, by the way, is actually Pz over the rational field. Because over the real field, so this is over the rational field, because over the real field, you can actually solve this. This is already complex. You know this from the two roots. This is different to 2 squares, and you get that and that. So that's over the real field, that answer. And of course, over the complex field, of course, is then you have the two roots, the two complex roots. And so that's how you do it fast, factorizing the 3 over the complex, over the real, and over the rational. And that's why I'll stop.